Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 3 2015-2016 Division A. Okay, question 1. One pair of opposite sides of a quadrilateral are both similar congruent and parallel. What's the most descriptive name of this quadrilateral? Since one side is like basically parallel, and no, the one pair of opposite sides is basically parallel, then you make another line to combine those two. Technically, this line and this line would be the same, and this line and this line would basically also be the same. So, then, and because they're similar and they're parallel, then this side has to be similar and parallel. So that basically tells us that this is a parallelogram. Parallelogram. So that's the answer. Question 2. Find the degree measure of the interior angle of a regular hexagon, rounding your answer to the nearest second. So what you do is to find the interior angle of a regular hexagon, you're just gonna have 360. I mean not 360, 180 times x minus 2. X is the amount of side length divided by x, basically. So this gets the interior angle. So heptagon is when the side length is 7. So x 180 times 5 divided by 7 is equal to 128.5914, etc. So you're just gonna write since you're gonna have to write in seconds, so you're gonna write it in HMS form, which stands for hours, minutes, seconds. So that's how I know it has to be in this form. So the hours is just the degree, which is 128. Just write the integer, 128. And then your calculator subtract the 128 out. And then whatever is remaining, multiply by 60. Don't round. And then you put the next integer, which is 34, and then put the apostrophe. Subtract the 34 out of your calculator, and then what is remaining multiplied by 60, and you should get 17. That's the last one. So that's the hours, and that's the minutes, and that's the seconds. So it's 128 degrees, 34 minutes, and 17 seconds. So that's your answer. Okay, in this figure, BECD is a trapezoid with bases BE and CD, with CD is equal to 15, ED is equal to 4, and BE is equal to 10. Find AE. So AE is X. So let's just, since they're similar triangles, ABE and ACD, we're just gonna have X divided by 10 is the same thing as saying X plus 4 divided by 15. Cross multiplying, we got 5x is equal to 10x plus 40, and we get 5x is equal to 40, so x is equal to 8. The answer is just 8, because x is equal to AE. Question 15, a certain polygon has 3 times the number of diagonals does it has sides. How many sides does this polygon have? So if a polygon has x sides, then the amount of diagonals it has is x times x minus 3 divided by 2. So basically, how many sides does this polygon have? A polygon has 3 times the amount of diagonals as it does sides. So you have 3x is equal to x divided by x minus 3 divided by 2. So basically, multiply by 6 the other side, so you get 6x is equal to x squared minus 3x. 0 is equal to x squared minus 9x. So 0 is equal to x times x minus 9. X cannot be equal to 0, so x has to be equal to 9. The answer is just 9. Okay. Number 6. 2 angles of a quadrilateral have measures 33 and 127. The 2 other angle measures are in ratios 3 to 2. Find the measure of the larger of the remaining angles. So we just need to scale these numbers, so then they kind of like, when they add up together, plus the 33 plus the 127 equals the total amount of the sum of the angle is in the quadrilateral. So we have 33 plus 127 plus, we're going to scale it by x, so it's going to be 3x plus 2x, because they're in the ratio 3x plus 2x. And that should equal to the amount in a quadrilateral, which is 360. So using your calculator, 360 minus 33 minus 127, and then divide by 5, so you get x is equal to 40. So the larger of the remaining is just the 3 version, which is 3 times 40, which is 120 degrees. So the answer is just 120 degrees. Okay. Question 7. The coordinates of 3 vertices of a parallelogram are 0, 0, 6, -2, and 4, 3. Determine all possible coordinates of the fourth vertex. So let's kind of draw up a diagram. So we have 0, 0. And we have 6, -2, somewhere here. And we have 4, 3 ish right here. So there's gonna be a coordinate right. So since these are parallelograms, right? So technically it has to be the same distance. So if we have a distance here, that means there's another one right here, or if there's another one right here. Or if we make a line here, then basically there's gonna be one here, which is the same, or it's gonna go down, which is right here. Or you have a line here, then this line has to either go up here and go down here. So there is 3 possible points basically we have to look for. So we have to look for this point right here, this point right here, and this point right here. So those are the 3 points that we need to look for. So let's just use 2 points, which is 0, 0, and 4, 3. So we're gonna use this point here and this point here. And now since we have now we have the remaining point, which is 6, 2, 6, -2. Now this could either go down or it could go up. So as it could go 4 and 3. So so from 0, 0 to 4, 3, then the 6, -2, you have to go to the other side. So you're gonna have to add it. So you have to add 4. So you add 4 is 10. Add 3, then that's 1. Or it could be on the top portion and it has to go down, right? So as the 4, 3 to go to 0, 0, then the 6, -2 has to go down to the other point. So you have to minus 4, so that's 2. And you had to minus 3, so yeah, -5 right here. So basically minus 4 from 6, 2, you basically do the exact same thing. You can add 4 and add 3, or you get minus 4 and minus 3 to get these 2 points. So those are your first 2 points. So you have 10, you have, you have 2, -5, and 10, and 1. And now you just have to look for the last point. Okay, so delete. Okay. Now we just need to look for this point over here. So we could use these 2 points. So we have from 6, -2 to 4, 3. And the one that corresponds to the 4, 3 is the 0, 0. So you had to add 2 from 4 to 6 to 2. So 0 plus 2 is 2. And from 3 to wait, sorry, I'm looking at this wrong. Oops. 0, 0. Wait, 6, 6, 4. Yeah, so to get from 6 to 4, you got -2, so 0 minus 2 is -2. And -2 to 3 is add 5, so 0 plus 5 is 5. So the last one is -2, 5. So these are the 3 answers. 2, -5, 10, 1, and -2, 5. So basically it just makes a picture when you have these type of questions. Question 8. Find QV. QR is parallel to ST, and let's kind of draw this out. Okay. ST is 10. QR is 25. And SQ is 28. So let's call this X, and this is 28 minus X. So we just need to find this blank right here. So we know they're similar, so we have X divided by 10 is equal to 28 minus X divided by 25. Because since they're vertical angles, these has to be the same. Actually, let's call these angle A. Then we know these are parallel sides, so this angle has to equal to this angle, and this angle has to be equal to this last angle, basically. So since we know the triangle is similar, we could use proportions, so we could just use this. Cross multiplying, we get 25x is equal to 280 minus 10x. So that's 35x is equal to 280. So x is equal to 8. So 28 minus 8 is 20. So the answer for number 8 for QV is just 20. Question 9. 3 numbers are randomly selected without replacement from the set 5, 9, 12, 13, and 15. What's the probability that the chosen number form a Pythagorean triple? So for it to form a Pythagorean, so let's just look at each number individual and see if it could be a hypotenuse. So because then it could be forming a Pythagorean triple. So if we have a 15, right, that could be a, imagine a 3, 4, 5, and you scale it by 3, so that's 9, 12, and 15. So 15 works because you have a 9, 12, and a 15. So 15 works. So there's one for 15. 13 works because you have a 5, 12, and a 13. That's a Pythagorean triple. So you have 2 of them that works. 12, 5 and 5 squared plus 9 squared is gonna be 25 plus 81. That's 106, and 12 squared is like 144. So it's not gonna be a right triangle. And 9 and 5 is not going to work because there are only 2 numbers, and you need like 3 numbers to make a Pythagorean triple. So the only ones that work are 15 and 13, so there's 2 ways. Out of how many ways can you choose 3 numbers? Which is just 5 choose 3. 5 choose 3 is basically combinations, which is 5 factorial all over 3 factorial over 2 factorial. Because order doesn't matter. It's 5, 9, 12, and 12, 9, 5 is basically the same thing. They're basically the same. Because technically, if you think about it, you have like if you have 5, 12, and 13, which is the one, we also have like 5, 13, 12, right? So scaling them just using choose would be like the same thing. Because if you do this way, then technically you have to multiply the top by 3, and you're gonna have this as permutate. But it's gonna simplify to the same thing probably. But just using combinations is simpler, so you don't have to do all that work. So 5 factorial divided by 3 factorial over 2 factorial, so that's 5 times 4 divided by 2, that's 10. So this is 2 over 10, which is equal to 1 over 5. So the answer is just 1 over 5. Okay, find the angle sum P plus E plus N plus T and A. So penta. So we have such a weird shape, but what I usually do in these cases is that I kind of use a similar shape to do the exact same thing. So I see a shape like this, which is a pentagon because it's 1, 2, 3, 4, 5, so it has 5 side lengths. So basically, I'm just gonna make a regular pentagon, right? And then you're just gonna expand the side lengths out. Sorry that this doesn't look like straight, but but these are straight lines. Okay. Okay. So these are straight lines basically. So we using our idea that I said before, which is 180 x minus 2 divided by x to get the interior angle. X is equal to 5. So plugging that into your calculator. So 5 minus 2 times 180 divided by 5. So each interior angle is 108 degrees. That's what I know. So this is 108. Since this is a straight line, right? Then basically this has to add up to 180. So this has to be 72. So 72 plus 108 is 180. Since this and this is basically the same side, this is a regular, there's gotta be a regular pentagon. Because we're saying this is 105, this is 105, this is 105, this is 105. All of them are 105. So it's gotta be a regular pentagon. So that means these two are the same. So this has to be 72 and this 72. So since a triangle adds to 180 is 180 minus 72 minus 72. So this angle right here will equal to 36. So since this is 36 and there's 5 of them, right? It's just 36 times 5. So the sum of PE and TA is basically 180. It's basically just like that. You could try it with like another example. Instead of like 108, you put 109, but you gotta subtract one from the other 108s. So you could have like 109, and this has to be like 107. But then they should like cancel each other out. Because if you make this to 108, you just have to minus 1. So you have to add 1 to here. So that makes 108. So it has to be balanced, basically. But it's always going to work out to 180. Number 11, an interior angle of a regular polygon measures 175 degrees. How many sides does the polygon have? So, basically, if they give me an interior angle, I'm just gonna look for the exterior, because if they're asking for the amount of sides, then basically what you do is that interior plus the exterior has to be 180 degrees. Because think about it, it's what is so an interior angle would be like let's say a triangle. This would be the interior angle, so this angle. An exterior angle would be the other one, the other side, basically. So that's where we're gonna look. So since they're made by straight lines, it's gonna be 180 degrees. So the exterior of this one is 5. So that's the exterior. And to find the exterior angle, it's just 360 divided by the amount of sides to get the exterior. Sorry, the exterior. And the exterior is equal to 5, so 360 divided by 5 is equal to x, so which is the amount of side length. So x is equal to 72. So the amount of sides I have is 72. So number 11 is just 72. It's basically just that easy. It's a faster method, but if you want to use the method that was using 180 x minus 2 divided by x, which equals the angle measure of the side length, so it equals 175. And it just takes a couple more steps. But if you want to like not waste time, you could use the exterior method. Question 12. A rectangle has sides 3 and 4. A second triangle is similar to the first and has diagonal 13. Find the second rectangle's area. So the first rectangle is 3 and 4. So technically, the ratio of the second one is in 3 to 4 because it's similar to it. So let's just kind of draw that. So we have 3x to 4x, and this is 13. Okay, so find the area. So since this basically a right triangle, but it's a rectangle, then you just have 3x squared, so that's 9x squared, plus 16x squared is equal to 13 squared, which is 169. So x squared would equal to 169 divided by 25. So x would be the same thing as saying x squared would be equal to 13 over 5. Okay. So the area of a of the second rectangle is just 4x times 3x, so that's 12x squared. So we already got x squared here, so just put it in. So 12 times 190 169. I'm sorry why I couldn't say that. 169 times 12 divided by 25, which should get out to like about writing in decimal is just 81.12. So that's your answer, 81.12. Okay. Number 13. Lines CM and BN are medians. So BM is equal to MA and CN is equal to NA. Intersecting at X. If the area of ABC is the entire thing is 60, find the area of the quadrilateral, basically. So we're gonna draw a triangle and then kind of rotate it to this side. So what we're gonna do is that we're gonna draw one more median. So this thing is equal to this is equal to this, and this is equal to this. So they are gonna meet at one point in the triangle. So they're gonna meet at X. And how I know this is because there is something in a something created by 3 medians, and it's called a centroid. The point of it that they intersect is called a centroid. So I know it's gonna intersect there. And a cool thing about a centroid is that the ratio of this line to this line is 2 to 1. So from the vertice to the point and the point to the line is 2 to 1. So that's 2 to 1. And the same thing applies to other lines, which is 2 to 1 here and 2 to 1 here. So angle to centroid and centroid to the side, 2 to 1. So based on that, we could use summer triangles. So if this is entire thing is basically 60, the area is 60, then basically half of it, because it's the median, is 30. So using this triangle right here, just this one right here, then it's gonna be 60. I mean 30 because it's half. So using that, we have this. We're gonna ignore the other line except this line right here. So we're just gonna draw that line, and that is in the ratio 1 to 2, right? So this is 30. So this would be 2. 2 plus 1 is 3. So 2, 1 would be, 2, 3. It would be 2/3 of the entire area. So times 30 is 20. So this entire thing right here is 20, okay? So what is saying that this entire thing is 20? So now we could use this triangle now, which what we have is 20 degrees. Since this thing and this thing are basically the same because that's the median, then basically this area is equal to this area. So since it's 20, just divide by 2. So this is 10 and this is 10. So we know that this area is 10. So if this area is 10 and this area is basically the same thing, then it's just 10 times 2, which is 20. So the answer is just 20 for the quadrilateral. Okay. Number 14. What is the smallest length that can be used in all three positions? Hypotenuse, longer length, longer leg, shorter leg of a right triangle with integer side lengths. So basically, you're just gonna use a if you know your Pythagorean triples, it's just like 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, etc., etc. I'm just gonna write 5 of them, because usually you just want to write 5. I like to go with multiple 5s anyways. So basically, it has to use for the hypotenuse, okay? So we have a 5, has a hypotenuse, so it already works there. It works for the shortest length, so it's right here, the 5. And now we just need it to be in the longer length, so it has to be one of the middle ones. So since this is a 5, right, you could just think about it as if you scale it, you could get like 6 and 8 and a 10, right? And you could just put this as like 10, 12, 24, and 26. Sorry, 26, basically. Then what you could technically do is, since it has to be a 5, right, it just has to be a 5x multiple. So the 5x multiple in the middle is 15. So you could put like 9, 12, 15, 15, 36, 39, and you have 8, 15, 17. And it could be used for the smallest, the second smallest, and the hypotenuse. The answer is just 15. So the answer for 14, for the smallest length that can be used for all three positions is 15. Number 15, the ratio of interior angle sums of n-gon and n plus 1 gon is less than 0.99. Find the maximum value of n. So using the formula, which is 180 times, let's say the smaller one is, let's just say n, right? So n, the amount of sides, minus 2. Basically, the sum of the interiors, right? Divided by when it's n plus 1. So 180 times n plus 1 minus 2 is just n plus n minus 1 is less than 0.99. So we just have to find n. So cancel out the 180s, and you have n minus 2 is less than 0.99 n minus 0.99. So that gets 0.01 n is less than 1.01, and n has to be less than 101. So the greatest integer is basically 100. 100 is less than 101. So the answer is just 100 for number 15. Number 16, quadrilateral QUAD, shown below, right here. QUAD has integer side lengths and perimeter 37. How many non-congruent triangles does AUD, okay, are possible? So first we gotta have to find the smallest possible like length for UA. So the smallest possible length is that the two of the smaller lengths had to add up to the has to be greater than a larger length. So let's say like UA is equal to x. So x plus 11 plus 10 has to be greater than 11. So x just has to be greater than 1. So the smallest integer is 2. So the smallest is 2. So we know that so far. So it goes from 2 to like some number. So now we know that it's since it's perimeter 37 QUAD, right? Basically, it's let's just say the two side lengths, right? For let's say UD is the biggest length out of QU and D, triangle QUD. So basically, two, as I said before, two of the smaller side lengths have to add up to the greater than larger side length. So the smallest possible they could do that's larger than 10 is 11. So if that's 11 side length for QU and a QD plus QA, which is 11, plus UA, which we will call X, is equal to 37 because that's the perimeter. So X has to be equal to 15. So the largest amount that they could go up to is 15. So it goes from 2 to 15. So how many numbers are from 2 to 15? That's 14. There's 14 numbers. So the answer is just 14. Because there's 14 14 numbers you could use for QA. So that will count as like how many triangles that you can make. Number 17. The interior angle of a regular polygon is 6 degrees less than the angle of a regular polygon with three more sides. How many diagonals does the polygon with fewer sides have? So let's say the regular polygon, which is the smaller the polygon with the fewer sides, is x. So the interior angle is just 180 times x minus 2 divided by x. And then you add 6. Because the 6 less than it is equal to the interior with 3 more sides. So it's 180. Where x is x plus 3, so that's x plus 1. Because x plus 3 minus 2 is x plus 1 over x plus 3. Putting them together, that's 186x minus 360 all over x is equal to 180x plus 180 all over x plus 3. This gets up to 186x squared, and that gets to 186 times 3 minus 360, which is 198, plus 198x minus 1080 is equal to 180x squared plus 180x. Move this up. Okay. Now, subtracting them together, you get 6x squared plus 18x minus 1080 is equal to 0. Divide by 6, 6x plus 3x minus 1080 divided by 6 is 180 is equal to 0. So x plus 15 and x minus 12. So x can't be negative because it has to be a side length, so x has to equal 12. And the amount of, let's move this up again. The amount of diagonals in a side length is basically, as I said before, it's just x times x minus 3 divided by 2. So plugging in 12. 12 times 9 divided by 2 is 54. So the amount of side length of the polygon with fewer sides is 54. So that's the answer for 17. 18. Using the figure below, find h in terms of x and y. So let's draw that out. That's x, that's y, and that's h. What you need to know first is that basically this triangle right here is similar to this triangle right here. How do you know? Because basically, since these are vertical angles, and this is, so let's call this angle A. This is also angle A. Since this is perpendicular to this line, and this is perpendicular also, that means technically this line is parallel to this line. So this angle, let's call it B, is this angle, and this C, this has to equal to this angle. So that's how. So we know that these are basically similar triangles. So let's call this side length A. Okay. So if this is A, then let's call this question mark. So x divided by question mark is the same thing as saying y over A. So question mark has to be equal to A times x divided by y. So let's substitute that in. So ax over y. And now we could just use this triangle right here. Since we know these are since this is a height, right? So this is perpendicular as is shown in the diagram. So this is also perpendicular, and they share this side length, this angle right here. So we know it's gonna be a similar triangle. So we have, let's say, the hypotenuse, which is just ax divided by y plus a, because that's the entire side length, divided by the height, which is x, is equal to this hypotenuse, which is a, divided by the height, which is h. So let's move this. Combining them together, we get a times x plus y all over x times y is equal to a over h. So dividing the a away, this is just 1 over h now. And then you find the reciprocal that gives x, y, and x times y and x plus y is equal to h, basically. So h is equal to xy and x times y divided by x plus y. So that's your answer. Question 19. Find the length of the shortest altitude of a triangle with 8, 15, 17. First thing you want to do is that you check that it's a right triangle. So you have x squared, 8 squared plus 15 squared is 289. And square root 289 is equal to 17 squared. So it does equal 17 squared. So it's a right triangle. So basically that tells me that we don't have to find 2 more side lengths. Because if it's a right triangle like this, right, basically you have 8, 15, and 17, then 8 is a height and 15 is a height. So the last height we need to look for is just this one. So the area is 8 times 15 divided by 2 is 60. So the area is 60 of this entire triangle. So the height times the base, so the height times the base, which is 17, divided by 2 is the area. So the height is equal to 120 divided by 17. And 120 divided by 17 is like a decimal. Is it's about 7-ish. So that is smaller than 8. So the smallest height is just 120 divided by 17. Number 20, find CD. Okay, let's draw this picture again. BC is equal to 3. AC is equal to 4. And AB is equal to 5. Okay. And AD is equal to 2. So since this is 2 and this entire thing is 5, this is equal to 3. Okay. So since this is a 3, 4, 5, we know this is a right triangle, basically. What we're going to use here is that since we want to find CD, this is the altitude, we're going to use something called Stuart's theorem. This theorem just helps us find the diagonal that cuts like a triangle into 2 triangles, basically. So that's what it does. So let's kind of move this a little bit up. We need a little bit more room. Okay. Basically, it states that one of the legs squared times the opposite side, which is 3, plus the other leg squared times the other side, which is 2, is equal to whatever the last side length is, which is 5, times the diagonal, which is x squared, times the diagonal squared, plus the last side length, which is 5, times the smaller ones, which is 2 and 3. So that's the theorem. It could work for any of these. Like if this was like right here and this was like 3.5 and like 1.5, right? It could work for anything. It just has to be you just had to get the appropriate side length and plug them in. So we already have that. So let's just solve for x. Right. So this is 16. That's 48. That's 9 and that's 18. This is 5x squared and this is 30. So subtracting that gets 36 is equal to 5x squared. So this 36 divided by 5 is equal to x squared. So x is equal to 6 divided by square root 5 is equal to x. And getting the square root 5 to the top, square root 5 over 5. Because you just multiply this by square root 5 in the top and the bottom. Square root 5 over square root 5 is 1. So it's the same thing. This is equivalent. So the answer is just 6 square root 5 over 5. That basically covers everything for the CCML Geometry Contest 3 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.